everyone, this is me Shrita Biswas. Welcome back to my channel dedicated to my juniors. So in my previous video we have been discussing about the contents, all the full portion revision of our 9th grade syllabus, right? So we had stopped in polynomials, in algebraic identities. I had explained all of them. Now let's move on to our third chapter, that is coordinate geometry. Now in our coordinate geometry, just give me a second. In coordinate geometry, we actually don't have any chapters here. We don't have any formulas over here, but we do have the Cartesian system. Okay, so let me just explain it to you. We have this thing. This is the x-axis, this is the y-axis, this is the x dash, this is y dash. Okay, now this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay, now if they have given you a few solutions, now you have to tell whether that will lie in the first, second, third, or fourth quadrant. Okay, so how will you know that? You can identify by looking at the signs. Okay, so how are the signs? Let's see. If it is in the first quadrant, then the signs would be plus comma plus. Okay, if it is in the second quadrant, it would be minus comma plus. If it's in the third quadrant, it would be minus comma minus. If it's in the fourth quadrant, it will be plus comma minus. Clear? So this is all about coordinate geometry, and rest I think it's given in the chapter itself. Okay, this is the main thing you need to remember. Okay, so this is the coordinate geometry. Then we have linear equations in two variables. Linear equations in two variables. Here, just one second. Okay, yeah. Here we don't have any formulas here either. But finding the solution of an equation, oh my god. Okay, finding the solution of an equation. What we do here, for example, if it's given p of x is equal to 3x minus 2. Okay, this is p of x. Now you have to find the value or find the solution of this equation. How do you do it? P of x is equal to 0. Or what's the value of p of x? 3x minus 2. This is equal to 0. Or 3x is equal to 2, right? We have transposed the minus to the other side. So x is equal to 2 by 3. Clear? Clear with this? Very, very simple. This is mainly what we have in linear equations in two variables. It's very simple, okay? Then we have introduction to Euclid's geometry. So here also we have no formulas to remember, but we have lots of Euclid's postulates and axioms. Okay, you need to learn them all. You have to learn them all because, even if this chapter has the least weightage in the exam, it's very important if you want to score like outstanding marks. Okay, so after this we have lines and angles. Yes, here we do not have formulas either, but we have a few things we need to remember. Okay, for example, let's say if you're given a straight line, and there's a line on top of it like this. Okay, this angle, let this be angle 1 and this is angle 2. So we can say angle 1 plus angle 2 is equal to 180 degree. Why is this? This is because they're a linear pair, right? They're a linear pair, right? Or you can say they're supplementary angles. That's also correct. Okay, so this is when it's lying in a straight line. Now, there is another thing I want to tell you in lines and angles. Chapter 6, right? Chapter 6, yeah, let's go. Chapter 6, okay. Chapter 6, lines and angles. For example, they're given two parallel lines. One parallel line and another parallel line. Okay, and it is cut by a transversal. This is what we have studied in 8th grade as well, right? So, I'm just refreshing your memory because this is also important in 9th grade. Whatever you study in younger classes is important. Okay, this is 1, 2, 3, 4 angle 4. This is angle 5, angle 6, 7, and 8. Okay, now angle 1 should be equal to angle 5. Angle 4 should be equal to angle 8. Angle 2 should be equal to angle 6. Angle 3 should be equal to angle 7. Now why is this? This is because of they are pairs of corresponding angles. Okay, I'm just writing angles like that. Okay, Then this is corresponding angles. Then we have alternate interior angles. Okay, so what are alternate interior angles? Angle 4 should be equal to angle 6. Angle 3 should be equal to angle 5. These are alternate interior angles. Now what about alternate exterior angles? Angle 1 should be equal to angle 7. Angle 2 should be equal to angle 8. Clear? These are pairs of alternate exterior angles. Okay, so all together collectively we can call them alternate angles. Okay, now after this we have co-interior angles. Co-interior angles, we have angle 4 plus angle 5 should be equal to 180 degree. There's supplementary. Then we have angle 3 plus angle 6 is equal to 180 degree. Sorry, angle 6. Okay, it's correct. So this is co-interior angles. Okay, these things you have to keep in mind. They're very important. Okay, now that's one thing. Okay, I've explained to you only one thing over here. This is only linear pair I've explained to you. There are other things also you need to keep in mind. There's this one thing called this one. When two angles are meeting like this, their vertically opposite angles should be equal. Okay, if I mark this as A, this is O, this is B, this is C, this is D. Okay, so angle AOD is equal to angle BOC. Okay, angle BOD is equal to angle COA, right? This is because of the pairs of vertically opposite angles. Okay, so this is lines and angles. Everything you need to know from lines and angles. Okay, and there are also basic terms and definitions as well. You need to learn that from the chapter. Okay, now we have triangles. Oh, what is these? Triangles. One second, let me just rub this for you. Okay. Triangles. Okay, triangles. So here in triangle chapter, we don't have any formulas, but we have congruency rules, which you have already done in 8th grade. Okay, so what are they? Four of them you have already done in 8th grade, and one new one, okay, which you have not done in 8th grade. So what are the ones which you have already done? Let me take a different color. It's getting boring. This one, yes. Okay, so triangles you have SSS, side, my favorite one, everyone's favorite one, SAS congruence rule, ASA congruence rule, and RHS congruence rule, right? These are the ones which you have studied before. Now, there's this new one which you have not studied before. Okay, so which one is that? That is AAS. What is this, bhaiya? AAS basically means in a triangle, in two triangles, okay, if this angle, let's say in this triangle and this angle, okay, let me name this ABC triangle, PQR triangle, okay? So if this is equal to, one second, if this angle is equal to this angle, and if this angle is equal to this angle, okay, and if this side BC is equal to this side, okay, then we can say triangle ABC is congruent to triangle QRP. QRP. Okay, this is why. This is because of AAS congruence rule. Okay, that. So you can see here two angles are equal and a non-included side. Okay, non-included side. If it was something like this angle, and this side, then this would be ASA congruence rule. But since it's not the included side, this is AAS congruence rule. Clear? Okay, now let's move on. Let me just rub this one for you. Okay, so this was triangles. Next we have quadrilaterals. So here, in quadrilaterals, yes, you have a few properties for parallelogram. You have the same properties for triangles as well. Okay, so yeah, for properties of a parallelogram, then you have the midpoint theorem. It's a very important theorem. Okay, I'll tell you. Okay, what's the midpoint theorem? Basically, if you're given a triangle, like this, okay, and this is ABC, and a line is passing through it in such a way that this point is E, this point is F, okay, and AE is equal to EB, and AF is equal to FC, which means E and F are the midpoints of AB and AC respectively, right? So we can say that EF should be equal to half of BC, half of the third side, and EF is parallel to BC. This is the midpoint theorem, nothing else. Very, very simple. And one more thing, okay, if in the converse of midpoint theorem, what happens in the converse of midpoint theorem? It's the same thing itself, ABC, and it's given that this line is passing in such a way, but it's given that this is parallel to the third side, and it's also given that AE is equal to EB. Okay, all these things are given. So what can we understand? We can understand that AF should be equal to FC. This is nothing but the converse of midpoint theorem. Okay, so we'll stop here at quadrilaterals and I'll continue in our next video. Okay, until then, bye bye.